Hi friends, now I'm going to speak about the techniques for Turing machine construction. For Turing machine construction, we focus on programming technique concept, which broadly classifies 5 techniques: storage and finite control, multiple tracks, checking of symbols, shifting over, and subroutine. And now I'm going to speak about the concept of storage and finite control. The storage and finite control simply means which is used to hold some amount of information in it. To do so, the state is written as a pair of elements, one exercising the control and the other storing the symbol. Here the states be Q0, Q1 and goes on. Symbol here is zeros and ones. Be accepted as zeros and ones as a binary input. Storage and finite control. I'm going to show one example problem to get clear about this concept. The main intention of this technique is that the symbol does not appear elsewhere on its input. It means if once an input has been given, nowhere in the problem it should be repeated. That's the main intention of this problem. Let us have one example. Consider a Turing machine that looks at the first input symbol, records in it finite control, and checks that symbol does not appear elsewhere on its input. Note that M accepts a regular set, but M will serve for demonstration purpose. Here M is given as Q, 0, 1, 0, 1, B. B the symbol, that is the input symbol. Rel of Q0, B, B, F. Here the states are Q0, Q1 and the inputs are 0, 1, B. The main intention is that the first component of the state controls the action while the second component remembers the symbol. And the input state should be of pair of elements, that is like this state with input Q0, 0, Q0, 1, Q0, B, Q1, 0, Q1, 1 and Q1, B. Here B represents blank symbol. Here Q0 and B be the starting state and Q1 and B be the final state. As I said earlier, the intention of this technique is that first component controls the action, that is the input symbol we enter, while the second component of the state always remembers the second. It means the first component will control the action while the second component state remembers a symbol. Here Q0 B, 0. Here B means that initially while we are constructing a Turing machine, we will usually have blank as an input symbol, and 0 means here 0 means it reads 0 and goes to the state Q1 and it moves right. Here it reads 0. Initially it will be blank, then it reads 0 and moves to the state Q1 and it remembers 0 and it moves right. The same process will be done vice versa for the input symbol 1. Here, this state. The same is done here also. Initially, in the step 1, Q0 is the control component of the state and M moves right. The first component of the M state, that is M state B, becomes Q1 and the first symbol seen is stored in the second component. That is, they are saying this as an M state. Therefore, the first component of the M state become Q1 here, and the first symbol seen is stored in a second component. Okay. And the step 2 here is as I said, that the intention of the problem is that whenever it repeats the symbol, that is the symbol appears, the same symbol appears, it should not do any action, it should skip and move. That is, M has a 0 as stores and continues to move. That means if it sees 0 or 1, again, if initially we remember 0. Yes, so once again, if we read 1 comes, 0 will be stored as such. It will be keep as such and moves. That is, it will be skip and moves right. The same process is done if 1 is stored and again we encounter 0 as a next element, as a next symbol. It moves on like this. In step 3, Q1, 0, blank. It means that if M has enters the final state, that is Q1, 0, blank. If it reaches a blank symbol, the M reaches the blank state. Q1, B, Q1, 0, B. That is Q1, B. Here, this they saying that as soon as the M state has reached a blank state, the symbol will be Q1, B. If it reaches a blank symbol without having the first encountered a second copy of the leftmost symbol. If REM reaches a blank in state Q1, 0 or Q1, 1, it accepts. They are saying that if it reaches blank state in Q1, 0 or Q1, 1, it just accepts and get replaces. That is, here 0 will be replaced as blank and blank will be replaced as 0 and moves left. Thus the process get halt here. When it has no longer has a available input to move. So in this problem, M gets halt in this step by either by accepting or rejecting the input. By this example, it gets accept the symbol and replaces.